As you can see, file will keep three information: name of the file, the start location, and the length. Now, if we say there is a file called count which start at 0 and length 2, that means I am talking about this. This is the count file. Why? It is starting in block 0 and it has length of 2. So 2 blocks given. Similarly, if we talk about file tr, a file tr, when we tend to talk about, would go through one simple way. It starts in block 14 and has a size 3. Let's see, block 14 and size of 3. So this would belong to file tr as it is shown over here. Similarly, other files can be. Now, if you technically see in this particular diagram, block 2, 3, 4, 5, 8, 9, 10, 11, 12, 13 are free, but 2, 3 has a discontinuation, or rather 2, 3, 4, 5 has a discontinuation of 2 blocks. Then again 8, 9, 10, 11, 12, 13 has a continuous allocation, further disallocation by 3 blocks and further. So basically a heavy amount of external fragmentation can be noticed. Going with the next technique which will overcome the continuous memory allocation issue, that is linked allocation. In this we maintain a linked list of all the data and wherever they are scattered, and we only store where we have this file being made available to us. Let's try to see this. In a directory structure, we have a file called Jeep. This file starts at 9 and ends on 25. So we know, for a linked list example, we know two things: where it is starting, where it is ending. But in this, each thing would be a node where one node points to the next node in the series. We know start and stop, but the linked list would keep on growing so that it can target some other location. So phenomena is fairly simple. We know where we start or where we should start and where we should end. So as we can see in the current diagram, the Jeep file starts on location 9. 9 refers to location 16. 16 after reading refers to location 1. 1 refers to location 10. 10 refers to location 22 and location 25, and 25 ends the entire file. So this is much better version compared to the other one. External fragmentation can greatly removed. So we say no external fragmentation. Any free blocks in a free list can be used for satisfying the request, which is a very good option. Size of the file need not be declared. As the file grows, the linked list structure can always grow further. File can continue to grow without any issue coming into this. So basically it is construction. This construction is considered to be a better option compared to what we had earlier in a continuous memory allocation. Going further, there are several disadvantages. One of the major disadvantage of linked allocation is we cannot have a direct access or a random access. This is because of one simple thing: we need to trace down the entire linked list structure to get to a particular point. So we only have is a sequential access. Consider you have a file of 10 KB and you want the last 9 KB of data. For this also, in this structure, you have to go from 1 to 9 KB uselessly, following the link and then finally getting the access. So obvious, the direct access is not supported directly. Second thing, there is a block which requires to store the information about file in its linked list. Basically the directory. This is what we talk about. Apart from that, entire integrity depends on the links. If due to some reason links are broken or disturbed, the entire system will collapse without any further ado. So next thing we are dealing with is the index allocation.